Hello, this is Team 4 presenting on the indoor air quality monitor. This first screen switches display between the current, date, time, and room temperature, followed by the current display of the carbon dioxide sensor values in parts per million units, and the particulate matter with diameter of 2.5 microns or less sensor values in micrograms per meter squared units. The sensor screen also provides a qualitative indicator of the status of the sensor value readings as good or bad. When the button is pressed, the device will display the next set of display screens that show the most recent maximum carbon dioxide concentrations obtained over the last 7 days, along with the time in which the maximum was recorded. This data is meant to provide the user with a weekly representation of critical times in which improved ventilation should be implemented. Because the monitor has only been on since the morning, the monitor will still display 0 values for the past days and no time. Once the button is pressed again, it will return to the first screen of the current data, and each press after will continue to cycle through the 2 sets of screen displays. In the event that the carbon dioxide values surpass the recommended threshold level of 2000 ppm, the screen will be interrupted by an alert screen that will remain visible until the carbon dioxide levels have decreased below the threshold. In a similar manner, whenever the recommended threshold level of 35 micrograms per meter cube for the particulate matter sensor is surpassed, the filter's fan will turn on until the sensor values fall below the threshold. So this is the alert screen that comes on whenever the carbon dioxide levels surpass the 2000 ppm level. And it will continue to alert until the values fall below that threshold, as can be seen there. And the particle sensor, once it reads values below 36 micrograms per meter cubed, it will turn off the filter. It's going 85, 68, it's going down. For the hardware components used, we use a PM 2.5 air and particle dust sensor, the Arduino Pro Mini, infrared carbon dioxide monitor sensor, real-time clock module, the FTDI Arduino programmer, a single pole double throw power switch, the display interface button, power jack adapter, the fan control MOSFET, the voltage regulator, and the LCD contrast circuit for the screen, and of course the 12-volt DC fan and the car filter. Okay, come down here. It's about to reach 36 and going. The particle, and then it will turn off the fan. See 36, the next time it will turn off the fan. It turned off. So some issues we ran into. While our PCB was being milled, we encountered an issue when an unexpected power outage stopped the board's mill. However, we now have our PCB and we will be moving our components onto it soon. The members of this team were Jacqueline, Aliza, Michael, and Lori. Jacqueline assisted with coding the switch interrupt for the LCD display and also helped to build the circuit on the breadboard and solder leads onto components. She also helped to plan and revise the PCB design schematic and PCB routes. Aliza was mainly involved with coding the MHZ19 carbon dioxide sensor and real-time clock module to store and display carbon dioxide maximum values for the past week. She was also involved in implementing the MOSFET voltage control for the filters fan so that we could control the 12-volt fan with the Arduino's 5-volt output. Michael worked primarily on coding the PMS 5003 particle sensor to utilize a threshold value to turn on the filters fan. He also coded the LCD screen formatting and prompt display and helped troubleshoot the real-time clock module and carbon dioxide sensor and particle sensor code. He was also in charge of drafting the layout for the PowerPoint slides, power list, and report. Lori mainly worked on the hardware components of the project, in breadboarding the circuit and soldering header pins on sensors and components. He also created the PCB footprints for our components and made the PCB design and schematic on Eagle. Lori also designed and printed the 3D printed case for the monitor's PCB. And all together, we worked on the presentation, slides, and the report writing and coming up with ideas, brainstorming, and overall troubleshooting problems in circuit and code.